Good afternoon, everybody. We'll be talking about zero downtime app deployment using Hadoop. Before we get into the presentation, I will just briefly tell what is this talk about and what is this talk not about. This talk is about how do you deploy your regular application that keeps your business ticking by leveraging the Hadoop infrastructure underneath. This talk is not necessarily about how do you have zero uptime on your Hadoop cluster itself. You have tools like SmartSense, ImBarry metrics, even if for upgrade right now, ImBarry 2.0 and above supports rolling deployment. I'll be happy to answer those questions. But this talk is more, as I said, how do you leverage your Hadoop infrastructure to bring zero downtime to your main applications that runs for your business. I'm Hemant Duraiswamy. I'm the solutions engineer at Hortonworks.
And I'm Wei Wang, the data scientist from Hortonworks. Give to you.
Thank you. Right. Agenda. I'll give you a little introduction on why zero downtime is important and how you get there and why. Then we have our own story, which has a very happy ending. We'll go to the reference architecture, and we'll have a demo too. We'll try to leave about 5 to 10 minutes at the end for question. If you can hold your questions to the end, that'd be great. Just, as much as allowed to answer the question, I want to be constrained by time too. For those of you here, as well as if you're seeing on the YouTube, if you can get to the question, there's a contact details of both our contact details at the last slide. You can email us or reach out to us over there. Also, we have a GitHub link to the code for all the demos in the last slide. All right, introduction. Why is zero downtime for your apps very important, right? So let's talk the language that everybody universally understands, right? The money talks, and everybody knows that. A random example, Expedia. The reason I picked Expedia as an example here is most of their revenue is driven from their customer-facing website. So that's the reason. And also, like before Hortonworks, I worked at Orbitz for about 6 to 7 years, and I've been close to the the way the travel websites work. And that's why Expedia is an example here. So Expedia, as per their public record, the revenue in 2015 is $6.67 billion. You do the math. It's about $18.2 million a day, or about $750,000 an hour. Let's assume that they do a deployment every other week, and each of the deployment window is like for 15 minutes. And by the way, this is a very conservative estimate because when we were experimenting continuous delivery back at Orbitz like 3-4 years back, when we were just the first year we were experimenting, we did like close to 1,000 deployments in a year across 150 different applications in the system. And I also heard like every time you refresh a page on Amazon, there's one or other more you get deployed. So at a very conservative estimate of 15-minute deployment window every other week, if they have that 15-minute deployment window, they'll be losing $5 million a year, which is slightly significant. The same figure for Amazon would be about 80 million. Anybody who follows Amazon would know that would be the difference between them reporting their EPS in red or green, right? Even though you discard all these metrics, there's one other metric that could keep your CTOs and CAOs up, all night, and that's the customer trust and confidence. I don't think the current age of customers are too patient or would love to see a 404 page. If I'm going to see a 404 page while I'm making my booking, probably I would never go back to that site. Unless they're selling me free tickets, right? So it's very important that you get the credibility through zero downtime. Now, how do you achieve that? The Hadoop is not going to give you zero downtime by itself, right? There's a lot of things that you got to do before in order for you to achieve that. First, you need to innovate. And there's a lot of tools, technology, and architecture. We'll touch base a little bit on those during our story, if you will. You need to monitor. You need to monitor the health of your servers, health of your application, if possible, even the heartbeat of your developers and the DevOps people. But please don't do it. And you need to react. Monitoring is great. I mean, I think a lot of people do it. But the real differentiator will be how are you going to react to something that's bad, right? I mean, and you got to do this all in real time. And what we call is actionable intelligence. The only way you can even decide if it's good or bad is you compare it with a historic data set, right? And that's when I mean, Hadoop really plays a role. I mean, it's great. You're streaming your real-time metrics to your server metrics into your system. But what are you how do you know if it's good or bad? I mean, you need to make those comparisons against your data set, and that's when we call it the actionable intelligence, where you look at the real-time motion, look at the data at rest for a long time, and you make decisions and react to anything that's bad or what. Right. This is a story. Once upon a time, I was a king and I had a website, right? It's great. So I decided I need to make some changes to this website. What we do, we change the code, right? We deploy it, we pull the server down. There's a 404. It could be for 2 hours, 3 hours. The server is down. And while I had this, I have new products on my website. This is great back then, but now, I mean, there's so many disadvantages. I don't even want to talk about it, right? And then we evolved. Now a lot of people do rolling deployment. I think this is the stage where most of the people are, and most of the people that I talk to are at this stage. Rolling deployment is essentially a process where you pull one server at a time out of the cluster. You take it off the whip. You let the outstanding request complete, and then you deploy a new version. You get the server back up. You put it back in the whip, and you continue the process across your cluster. Right? This is great. I mean, trust me, I have no reservation against it. But this is great for things like installing your Hadoop cluster itself, because you do it once a year or maybe once or 2 years. This is great. But when you think about having hundreds of applications running within your business system and it has to be done, I know companies who do it yearly. Back in my previous work, we had a deployment window at 10 a.m., 3 p.m., and 8 p.m. every single day. And it really doesn't scale to that kind of, I mean, it doesn't scale that kind of deployment cycle. One other thing is this is really a near zero downtime, right? You think about it, there's always an active request sitting on the server, right? Maybe there's a session stickiness where you save the session data on that particular server, and once you even pull out, you're losing the customer on that session, basically, right? And even if you think that you're losing about 10 customers per server per deployment window, that's still a lot of customers. So this is only a near zero downtime. It happens. It just puts a limit on the amount of innovation that you can do, and it's a lot of operation. You are still monitoring your servers coming up, and the biggest thing is, say if you somehow you had this bad app version go through the cracks, and once you start this rolling deployment, there's really no way to stop it. I mean, when you're doing like innovation at the speed where a lot of modern applications are happening, then there's chances that there's always a bad version which goes that your real ability to detect the bad version early and learn fast, and I mean, they always say fail fast and learn fast, right? I mean, you're really not achieving much by zero downtime. So here's the end game. So for the purpose of the rest of the reference architecture and demo, I'll talk about how do we innovate, how do we do at-will deployment, or continuous deployment, how do you really learn the whole feedback loop, right? How do you learn the metrics, how do you react to those things, and all this using Hadoop in real time. Right? So let's say, let's do I innovate through microservices, and most of the talk a little bit of microservice. What microservice really means is your web page is made of about many little services. So that way, if I'm a developer for a particular app, I really don't care about the rest of the people. I just keep developing by myself, and when I'm ready, I push it to the master, and really there's no dependency between. You try to eliminate all dependency between different modules, and you just develop each module as a service, and that's how they interact, right? So there's a little header module there. There's a search module. Then the multiple modules. This is just, again, just for demo sake, right? So that's one of the innovations. Deploy at will. What it really means is you develop the code and you push it to the master all the time. It's not you work backwards from your release schedule, right? You develop today, you push it to master. That's continuous integration. Every time a code gets to the master, there's a Jenkins or whatever tools. Again, Jenkins is my example here. So Jenkins goes and runs your bunch of test cases, right? If it succeeds, it builds a jar file. If it fails, then you just publicly shame the developer, right? I mean, honestly, there should be some hooks that every single unit case that even runs by the Jenkins should have run even before you push the master. And only when it successfully passes, you'll be able to push the master. So this is all making sure. I mean, obviously, this means that you need to have solid test cases. So again, you push the code to the master. After every code goes to the master, you compile it, you run the test case, you package it, and you schedule for deployment. It's up to you. I mean, whether you want to do one deployment every 2 weeks, or you do it once a week, or you want to do once an hour. It's up to you. Whatever your deployment cycle is, again, it has to be automated, right? Excuse me. And the next thing is learn and succeed, or fail fast and learn, whatever the case is. I'll touch a little bit about canary deployment here. Canary deployment is you have stages of server, stages of clusters of servers. First, if we go to the stage 1 server, I can give my. I don't know. So the stage 1 is really for you to, it's a stepping stage. So once you get your new app version ready, you go to the stage 1 server, which is a very controlled traffic, maybe 0.1% of your traffic. You control based on anonymous ID, like, I mean, like if this customer really is going to convert, or is just going to browse around. Based on those logic, you get a new app into the staging 1 server. You compare the metrics against the pool of servers or previous version. If you feel good about it, you go to the stage 2. It's a much more controlled traffic there. Again, you compare the metrics, the conversion, the app performance, the server performance, and all those things. And then if you're really happy, you go to the complete pool of servers. If you're not happy at any point of the stage, you roll back. And it's important when you do this to monitor and compare and provide instant feedback, right? These are the important things that you have to do. And also the A/B testing. A/B testing is really how about you change your look and feel about the page, and how is that going to impact your top line, right? I really, to this day, when I see a page that like we are so used to have an X button on the bottom right. I've seen so many websites which has cancel button over here and OK button here, which is I mean, I hate such sites because I always see that cancer. Nobody reads the website. They go by intuitive feeling. And even back in my previous company with Orbitz, you won't imagine by changing just the display picture of your hotel, it increased or decreased your conversion rate by about 30%. Just whether you put the entrance picture or you put the room picture, it matters a lot. So, I mean, you have to learn. I mean, the whole point of doing that is there should be some mechanism to get the feedback back into the business users or app developers, right? All right. This is my for the demo purpose. This is my reference infrastructure layout. Let's say I'm going to run a header module on 3 servers, so 1, 2, 3, search module on 4 servers, and really I'm not running any other modules. And we'll be demoing 3 use cases. Use case 1 is my server 3 goes in a bad state for whatever reason, right? How do I do that? The proportion of, I'll be monitoring the access logs there, and the proportion of 404 plus 503 is higher than the rest of the server pool. So that's, and we'll be alerting on that. Use case 2 is the server 06 goes slow, whatever the network connection is clogged or whatever. So how do I do that? Again, I monitor the access log, look at the latency, and if I compare it against the pool of the server, if it stands out, then I alert it. I take the server out of the pool, I reprovision the server, put it back on. Server use case 3. I deploy for conversation's sake. Let's say that's the stage 1 canary server. By the way, do you guys know what the canary is? That's actually a bird which was used back in the day in the coal mines where they let the bird go in, and if the bird dies, then it means there's a lot of poisonous gas there. So poor bird. So server 7, I put a bad app version. And how do I see if it's a bad or good? I monitor the app logs, not access log, but app logs, and see how many error and critical messages I get it compared to the loop, compared to the previous version. And if it's same or about the same, I leave it. If it's beyond a threshold, I roll back the version and just kill the version, right? This is a reference architecture. The servers generate access logs and application logs. Feed into NiFi. HDF, I mean, honestly, it's such an easy thing to do. I wish I had a HDF like 3-4 years back. I would have killed my architecture. This is so easy. I'm going to demo that. From HDF, I put it into HDFS for historical storage as a raw file, no formatting, no manipulation, nothing, just a raw format to HDFS because logs, everybody wants to put in the log for future analysis. As well as I stream it to Kafka. From Kafka, there's a storm topology which reads all these things and derives standard deviation as on set parameters. It's completely customizable. For right now, we do these 3 use cases. We derive standard deviation on the 404 and 503 as compared to 200. We derive standard deviation on your server latency. We derive standard deviation on your critical and error messages on your app logs. From storm topology, we put it in the Hive for analytical purpose as well as Solar. Connect to Banana for real-time viewing and alerting if possible. And this is what our demo is. And further, this is not there in the part of the demo just because we don't have real servers. But what you should actually be doing is read the data from Solar from the NiFi, and then trigger an Ansible script or whatever on your server, either to reprovision the server or take it out of the VIP, or even roll back your versions, whatever your deployment architecture is, right? So with that, let's move on to demo. This is my log prep, right? So I'm starting all the servers in good state. So there's all 7 servers. I'm telling the access log. These are all made up log files, by the way. Of the thing, this is the access log. So as you see, it has the server parameters, all the things, and it has the status code, the third from the last. It has the server latency, second from the last, and those are the 2 critical parameters that we make. I'm making one server bad, which is a server 03. So if you will see, server 3, now you see there's a disproportionate amount of 404 and 503s on that server. So now I'm making my server 6 go slow. And you will see higher latency on the latency column. It's all 8 seconds, 6 seconds. Wow, love to wait those such long. So app logs, I'll just give you how an app log would look like. App log on server 7. It's just made up messages, yada yada. It's all info, right? It's a search module 4.0 is the version. Search module is the name of the module, 4.0 is the version name. Now I'm going to deploy a bad version, which is 4.1 on the same server. I'm going to tail the same app log. So now it's 4.1, the search module, but you see a lot of error and critical, which means there's something bad on the module itself, right? Right, this is my NiFi flow. There's multiple ways you can get all the access log or app logs. Over here, I tail the file, but you can get a syslog. You can listen to a syslog UDP port or whatnot. And actually, it's a very UI driven. You can see the how much data is being queued. You can see how much data has been flowed in the last 5 minutes. You can see data provenance of how the data came and what has been done to the data, what it transformed. And here's where I put Kafka process. I give 30 concurrent tasks, and here's my topic name. This concurrent task, it's a whole different topic. I base it out of what is my mean mean load on my servers. You can go by either max load or whatever. So similarly for app logs, again, I'm doing a merged content. Just I don't want to push every single data back into my HDFS. For demo purpose, I want to group it up by either 100 message or 150 KB, whichever the highest. And I update certain attributes like the file name, directory name. I throw it into put logs to HDFS. Literally put logs to HDFS is drag, give the HDFS site, and give the format, the folder. That is, I mean, I couldn't think of any other easier tool. The only thing I would hate this is sometimes I feel like if I do things too easy, something is wrong about it. So other than that, this tool is great. Right. Here's so I'm tailing my Kafka console for the logs. So here are the logs that streams to Kafka, and it's another access logs. Right, and just Hadoop FSLS on the logs that I've saved. Here, pretty much that. With that, forward to Storm, I'll give it to Wei. I know I took up more time than what I should have, sorry about it. That's long.
Yeah. So right now, Heyman just put all the log data into the Kafka, and my work will start from Kafka, run using the Storm to do the calculation, and then send the calculation result to Solar. We use Banana for the display purpose. So here is the very simple version of the Storm topology. So first of all, we have a Storm Kafka bot. We'll read the message from the Kafka topic, and then send it to the aggregation bot. And at the same time, we start a timer bot. We can, and for this example, we set every 30 seconds. We aggregate the result for aggregated messages from the Kafka topics. And then we send the aggregated result to the next bot we call the calculation bot. from here we calculate the Z-score. The Z-score the formula is very simple. So in English word, I can say this is the Z-score is the normalized version of the deviation from the average. So because actually we can, this is a real time series data. We can use time series analysis or some other fancy analysis. But for this purpose, for this monitoring purpose, we only use the mean and this Z-score. That would be good enough. And then we send this calculated result to the Hive bot for the further analysis if we want to, and also we send it to the Solar for the display purpose. So since we for the previous one, this only for this topology is only for one metric calculation. Total we have 3 metrics to calculate. So this topology looks a little bit messy, but it's easy to understand. So, and then here is from the Storm UI, we can see, so the Storm UI will give us a lot of statistics and how many messages has been executed to how many messages has been acted. So it's very easy to control, to monitor the whole process. So yeah. So here is the final result displayed in Banana. So from in the upper left corner, which is analytics result for the server response code. That means if the server has the response code 200, that means we're okay. If have other code 404 and 503, some other code, the server will is in the bad situation. From here we can see the average for the server 3. The average response is only 53%, much lower than any other servers. And the Z-score is -10, is lower than 0. It's a lot. So I think this server should be taken care of. And for the other metric, it's the server latency. So we will see the server 6, the average response time is 6 seconds. So that's much longer than any other server. And so the Z-score is still much higher than other server. So we should consider this server as well. And also we do the same analysis for the app version. From the lower left corner, we can see the app server 7 search module. So this ratio is only 33%, much lower than the other apps. So the Z-score is very low compared to others. So which can give us very clear idea which app and which server we should pay more attention to. And this Banana is auto refreshed every 30 seconds. Actually, we can set up to every 5 seconds, 10 seconds, 30 minutes as well. So this screen will flash every 30 seconds. So let's see the real demo. Where is it? Okay, let's see. So let's start from the ImBarry. I think everybody knows ImBarry is the Hadoop management tool for HTTP, HDF. And in here we can have the control panel that the dashboard can show us a lot of very interesting metrics to manage the platform. And since in here we only installed the necessary component for our analysis purpose, we install like Storm, Kafka, and the Hive. And also from here, let's see the NiFi. So from previous slides, Heyman has a demo, but here is the real thing. It's very easy to control. This UI has a very good UI. It's easy to manage, to create the data flow. And here is the Storm UI. From here, we will see the real. Just wait a second. Okay. From here, we can see the real statistics, and this is the monitoring matrix for the boat, for the spot, and also we can see the visualizations for the time. And also, people are always interested in what is the latency for a message from end to end. So we can, from very top, we see the complete latency. And for every single bolt, we can see the latency. It's very easy for us to know what's the capacity of the whole system. So here's the Solar. Oh, sorry, it's not. So let's move on to the Banana. So Banana here is the analytics result display. This one will refresh every 30 seconds. From here, we can see, let's see, which one is bad? Oh, okay, see, from the server 3, we can see, it's hard to say, right? It's only 45%, much lower than other. Can you see it? Can you increase that? Okay, that'd be better. Yeah, from here you can see the response is 57% lower than another servers, and the Z-score is low. And for here is latency statistics. And let's see, the server 6 latency is the 6 seconds, right? And then the Z-score is higher. Okay, let's see. I think it's automatically like refresh every yeah. Okay. So here is the result for analyzing the app version. We'll see the apps at server 7, the search module has some problems. So that's it. Go back to the side. Any do you have something to say? Okay. So oh, I see. So like there's one more page. So I see. So here's us, and you can at the end of the page we will see the two GitHub, and on the top is for the log generation, log simulation, and for the 9.5 deployment for the Banana setup is out there. For the second part of the Git is for the topology. For the Storm topology implementation, I'm using Java. All the code is there. So any questions?
Yep. I want to leave last 5 minutes or so for questions.
That's nice. Okay. That's good. So, ready?
Thank you.
Thank you.